Good morning, grade 8s. I hope you guys had a great weekend. Today we're going to jump into chapter 9, which is linear relations, and we are going to start off with analyzing graphs of linear relations. I have posted the blank notes, so you can print those off if you choose. If not, you can just write it out in your notebook. We're going to start off with some keywords. First one is relationship, the way in which two or more concepts or objects are connected, or the state of being connected. Table of values is a chart showing two sets of related numbers. For example, we have our x and our y's, and those are related. Variable is a letter that represents an unknown. Formula is a mathematical statement that represents the relationship between specific quantities. An example is C equals pi times D, where C is the circumference and D is the diameter of a circle. An equation is a mathematical statement with two expressions that have the same value. The two expressions are separated by an equal sign. So we have 3a minus 2, that's one expression, separated by the equal sign. 4 is another, and that creates an equation. An expression is any single number, single variable, or combination of operations, plus, minus, multiply, divide, involving numbers and variables. An expression does not include an equal sign. So x plus 9, 2y minus 7, 8t, and 5 are all expressions. And then lastly, we have linear relation, a pattern made by a set of points that lie in a straight line. So as you can see here, if we were to connect these points, that would create a straight line. So we know that that's a linear relation. So I recommend you pause the video, make sure you get these definitions down, and then you can press play and continue on. Okay, so first thing, make a table of values from a graph. Well, we have a graph here that's cost of baseballs. We have total cost on our y-axis and the number of baseballs on our x-axis. Step 1, describe patterns you see on the graph. Well, there are any number of patterns we can write down. I'm going to give you an example, and I will type that out right here. Okay, so 1 could be 1 baseball costs $3, 2 cost 6, 3 cost 9, and so on. So for every baseball you multiply by 3 to get the cost. So that's one example. Another could be the graph shows that to move from one point to the next, you go 1 unit horizontally and 3 units vertically. The points appear in a straight line. I'm just going to shrink that, try to get that to fit in here. That I'll change the color so that you can see it better. Okay, so those could be some of the patterns. Now, we're going to make a table of values from the graph. So using our graph, we need to always put our x values in the first row or column, and our y comes next. So in this case, our x, we've labeled it B. And our y is C. If our B is at 1, our C is at 3. When B is at 2, C is 6. When we have 3 baseballs, our cost is $9. When we have 4 baseballs, our cost is $12. If the relationship continues, what is the cost of 14 baseballs? Well, if we look at our pattern here, we've already talked about our patterns a little bit. 1 baseball costs 3, 2 costs 6, 3 costs 9. For every baseball, you multiply by 3 to get the cost, right? So this is going up by 3. This is going up by 3. It's a little bit too. So we're going up by 3 every time here. So for every 1 baseball, we are multiplying by 3 because 1 baseball times 3 is equal to $3. 2 times 3, $6. 3 times 3, $9. 4 times 3, $12. So the relationship is 3B. So if we want to know what it's going to cost for 14 baseballs, we just need to substitute in 14 for our B, and that's going to give us 3 times 14 is 42. So 14 baseballs would cost $42. Okay, next example here. Nicole's rate of pay. So describe patterns you see on the graph. So I'm not going to write them all out. I'm just going to talk through them. So for example, the graph provides data on the pay Nicole receives for each hour worked. The pay for 1 hour is $10, 2, $20, 3 hours, $30, $40, 4 hours, $40, and so on. The points appear in a straight line. So the graph shows a linear relation. And the graph shows that to move from one point to the next, you go 1 unit horizontally and 1 unit vertically. 1 unit horizontally, 1 unit vertically. So we will say a pattern that we have is a linear relation. And what is Nicole's hourly rate of pay and how do we know? Well, for 1 hour, she gets $10. And how do we know that's her hourly rate of pay? Well, when she works 2 hours, she gets $20. So that's just doubling it. When she gets 3 hours, she gets $30. So it shows on our graph that for each hour, that Nicole works, because for each hour that Nicole works, she gets $10 more. So $10 because the graph shows an increase of $10 per each hour worked. Okay, and now we're going to make a table of values here from the graph. Remember, this is always going to be our x, this is going to be our y. In this case, our x value is t for time, and our y value is p for pay. So for time, 1, 10 for p, 2, 20, 3, 30, 4, 40. So is it possible to have points between the ones on the graph? Explain. Well, if we think about that, is it possible that Nicole could work for 2.5 hours? Yeah. So if Nicole were to work for 2.5 hours, let's say, which is right between 2 and 3, she would get paid $25. So answer, yes. It is possible because Nicole could work for 2.5 hours and get paid $35. Therefore, why can't I remember? No, that's not right. There's no E in there. Therefore, the point would be between 220 and 330 on the graph. Okay. So that is the last of it, and then I have one show you know coming up next. So here I want you to give this one a try on your own. Try to answer all these questions, pause the video, give it a shot, and then press play and continue on. So make a table of values from the graph. Step 1. Remember, first column's got to be our x. In this case, that's r for radius. And this is going to be d for diameter. We're going to make a table of values. So when the radius is 1, our diameter is 2. 2, 4. You can already see the pattern. 3, 6, 4, 8, and 5, 10. Okay, what is the diameter of a circle with a radius of 8? Well, if we look at this graph, we can find our relation. So our relation here is r times 2 is equal to d. So 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times, and whatever, and so on and so forth. So if we have a radius, I'm just going to put b over here, 2r is equal to our diameter. So then we can show our substitution. 2 times our radius of 8 is what we are looking for, is going to equal to 16 centimeters. C. What is the radius of a circle with a diameter of 22 centimeters? So now we're working backwards a little bit. If we know that 2 times r is equal to the diameter, then how would we find out what r is? Well, we want to isolate our variable r and get that on its own. So 2 times r. How do we get rid of that? We use opposite operations. So we're going to do the opposite of multiply by 2, which is divide by 2. What we do to one side of the equation, we're going to do to the other. And that leaves us with r is equal to diameter divided by 2. So now we can show our substitution. I'm just running out of space, so we'll do this. So I know that r is going to be equal to, well, it's asking if we have a diameter of 22. My radius is going to 22 divided by 2, 11 centimeters. Okay, last question. D. Is it reasonable to include a point on the graph for r equals 4.5 centimeters? Explain. Well, let's just look at this. 4.5. Is it reasonable to include a point on the graph for this? Yes. In short, yes. Why? Because you can have a radius that it doesn't have to be a whole number, and we can show that our diameter, and it's still part of our linear relation. So yes, it is reasonable to have points between our given points. All right, so that's all for this lesson. I want you to do the one last thing provided on Google Classroom. Submit that to me today by 3 p.m. and we will reconvene tomorrow morning.